So that's what we're trying to show you here is where are my satellites or SVs, and understanding how to position yourself to not become an obstruction which would block these satellites, which goes into avoid blocking satellites. So each receiver, whether you're using a handheld or an external antenna, it's important that when you're using an internal GPS handheld to know that your body can be can potentially cause problems or multipath. So understanding how to orientate that internal antenna correctly is very important. Another way around that is using use a range pole in an external antenna. However, we have seen that many folks, due to budgets, try to get by with just the geo without an external antenna because of cost. Like I said, at the end of this presentation, we'll show you some non-Trimble alternatives to an external antenna that might be more affordable. But if you are working in a more harsh GNSS environment when collecting data, you can use an external antenna. The other thing that trying to show here is that by knowing where the satellites are, you're able to increase collection yield, which is important to best field practices. So if you're using a GNSS receiver today, the use of planning tools aren't so important as they were in early days when it was just GPS only. However, the takeaway here is try to avoid blocking satellites while you're collecting data. So the first slide was trying to show you where the satellites are. Second thing here is just trying to know that blocking satellites. So this is trying to just a visual on that. So you can see my coworker Zach here is sometimes the best way of collecting data isn't the easiest. And what I mean by that is, you know, in this particular scenario, he has trees to the south and he has to face to the north. Well, he can take a knee and now he's given helping assist in being able to get higher signal to noise and not obstructing satellite signal. Or if you don't want to do that, you don't like taking a knee, what we're trying to show you is you could use an external antenna and then you don't have to worry about it so much. External antennas also assist with getting higher yield, which is going to assist in getting better signal to noise, which is going to assist in better positioning. The next common error we see, or something that is important, is positioning the antenna appropriately over the target. I've seen many times that people buy a geo decimeter unit or a decimeter commercial unit, whether it's a geo or an external receiver. However, I see them trying to take a position of a feature in the field, you know, several feet away. To me, that's kind of if you're buying the wrong tool for the job. If your accuracy requirements are only several meters, you probably shouldn't be looking at a sub-decimeter handheld. But most of the people, when they realize that when you go to them and you explain to them what they're doing, they actually are wanting trying to get an accurate position on a feature. So understanding how to position that antenna properly or a point or a feature is very important. So several things that are common mistakes are setting the correct antenna height. That's important if you're wanting vertical. Holding the antenna directly over the target of the feature instead of being 3 feet away, understanding where the antenna is, and then proper placement of using a range pole for if you're wanting a range pole or a monopod pole for accurate vertical. Remember, nowadays on carrier-based, and we'll talk more about code and carrier-based receivers, on carrier-based receivers, you actually are collecting three-dimensional data, so you can be using those type of receivers for both horizontal and vertical. So it's important to actually make sure you are accurately telling what the vertical is, which is keying in the antenna height, and also selecting whether you use an external pole or a monopole. So what this picture is kind of tying into the previous slide is know your antenna, where it's at, and in this case on the far right you see the the antenna is placed directly over the stake. He's not 3 feet away and measuring that stake, and he's got the antenna about as accurate as he can over that point for a plus or minus decimeter unit. In the middle you see it's a lot easier when you're using a pole with a finite point, a exact height of 2 meters, and the antenna is directly plumb using a level that's on the pole. And then on the left, you know, again, the antenna is placed near the object that is supposed to be measured for horizontal position, not, you know, standing 4 or 5, 10 feet away. And that's what we're trying to show here. So we're going to transition now into, Trimble uses 2 acronyms to define accuracy is what they say, but it's really precisions. And what I mean by that is there's a PPA indicator, which is predictive post-process accuracy, and there's a CEA indicator, which is current estimated accuracy. And PPA is used to show you live in the field what your post-process accuracies, I would say, could be or will be, meaning if you are matching datums for datums. But let me show you here what I mean by clicking on this movie here, and I'll move this to right here. What we're showing here in this movie is switching from integrated SBAS to uncorrected GNSS. So the real time goes away, and you can see that in the upper right, I'm going to move from 16 centimeters. And what I'm trying to do here in the setup under horizontal accuracies, I'm going to say I want to show horizontal, but not in the field, post-processed. Okay. It's important that when you set this up that you're selecting the correct distance of your baseline length. So if you select it too closely, the positions will be overestimated. So by setting this up to be able to show horizontal post-process, now if I click into the upper right-hand corner, I'm going to be able to show you that how I can play with the settings to reflect things. So in this example, we're trying to show a couple things, that my carrier time is 2 minutes, if you see that here on a carrier time, and that when I start to collect a point here, and I'm logging positions, you're going to see that the accuracy here is 12 centimeters. All right. Now, what's important here is to know how to change that setting from to show in the field horizontal, real time, or post processed. Okay. Now, this movie was trying to show you PPA settings. And you notice that it's important. The other thing we're trying to show here is that the carrier time you prefer at least 2 minutes of carrier time before you start collecting your data. So I guess what I'm trying to show you in this quick video clip was a lot of people don't know that under status receiver, it shows the carrier time. And with a carrier-based receiver, it's important to have 2 minutes of carrier time prior to start data collection, and there's also settings to make the indicator in the upper right, which is either current estimated accuracy or predictive post-process accuracy, and that's defined by setting it up under setup log settings. So the current estimated accuracy is is used to show your estimated accuracy when collecting data live in the field, and that's with real-time or autonomous. And so I'm going to click on this little movie clip that I made here, which is showing CEA, and which is current estimated accuracy. And right now you see we're autonomous, about 6 meters. So I switched to an external source, and in this scenario I'm using a VRS connection to a Colorado VRS Now subscription, and I make sure my external source button is pushed in, and I'm now waiting for real time. One way to check that is status real time, and now you see that I'm connected, which is important to know your uptime, and that I'm getting some data, and my last correction is about 1 second. So these are important factors that tell you whether you're using a single base up in Alaska correctly. But it's also important to know now by setting up my real time, and I'll rebuild my satellites, and I'll get up to enough satellites and I switch to the real-time source, and under setup log settings I'm able to go horizontal in the field. And a little trick here is I usually have it log just 10 positions under point vertex auto pause of 10. And once I confirm these things here in this little video clip and click done to save this, what I want to show you is how once you start your data collection here in the field, it's showing you, see, when you click on that CEA indicator, it tells you estimated accuracies in the field, horizontal and vertical, and also estimated post-process. So based on how you have that log setting, it's either in the field or post-process, it will show you that up here in the upper right. So sometimes people haven't changed it from post-process to real-time, and they're doing real-time, and up top in this upper right it says 30, 40, 50 centimeters, but real-time actually they're 10 centimeters. At any time you can always click on that icon, like I said, and then it will show you real-time in the field or post-processing. But the primary indicator is what it's set to by the log setting, and that's what this little video clip was trying to show here. The next important setting that is often not set up correctly is log now, log later, or vertex, understanding these three things. I feel that this is a very important setting, and I personally wish that Trimble would actually have log later set by default. But if you don't know this, every version of TerraSync, log now has always been the default. And log later is much better, and I'll explain why. A log later allows you to prematurely start to collect attribute collection before or while you're walking up to a point. For example, if I was walking up to do some tree surveys and measuring diameter, breast height, or type of tree, condition of the tree, I can usually do those attributes as I'm walking towards that feature. Or a utility, for example, as I'm walking up to a fire hydrant, this is a Clow, Rich Ranger, and Mueller, I can tell it's 2 2.5s, and a 4.5s. If you were logging now, which is the default, as soon as you hit log fire hydrant, it would start collecting positions as you're walking to that fire hydrant. That would be bad because the mean of all those positions is the ultimate position of that feature. So by logging later, I could start walking to that feature, collecting attributes, and then when I get there, hit the log button to physically measure the position. So what this is also saying is what I just mentioned. It prevents collecting unwanted positions, which is important. I believe anytime you can improve safety, and I've been doing this for over 25 years, it's important to be able to, when working, always try to improve safety. And by logging later, it allows you to kind of focus on the collection process and not be worried about logging. It allows you to collect the information and then move in quickly to just take your positions and move out of the way. So that's how you're improving your safety. It improves quality data collection, and how's that? if you're logging now, especially like when you're doing a line feature, you're immediately logging positions even though you're standing still because the accuracy of the GPS receiver is not perfect. Even at centimeter and decimeter, it's worse, and even at submeter, it's very, it's not so. You'll start to see this squiggly line at the beginning of every line that you collect, and then logging later also reduces the feeling of feeling rushed. I've been doing this for many years and still feel rushed if I have log now. And so what I'm going to show you real quickly is a clip about log now, log later, and log vertex logging. So if I go and collect under options, I'm able to switch it to log later, and I can change the time to at a 1 second interval, so it's super fast, and that's great. So if I go in here to switch it to log later, and that's what I did, just confirmed, I'm able to now collect a line, and you notice it's immediately logging data. I key in line and then I start walking. Most people can't collect data while they're in type at the same time. It's like walking chewing gum for some folks. So you'll see that I log this line, and this is a decimeter system, as you can tell by the 10 centimeter accuracy in the CEA indicator. So you're not going to see it as exaggerated as in a sub-meter system, but is there a better way of doing this? And certainly there is, and that's, you'll see as I zoom into this line, it's kind of squiggly. And in a centimeter system, it would be even more wiggly. But then in the beginning, because I was standing there and it was logging now immediately, you see you'll always have this remnant of position to position line drawing, which has got to be cleaned up into a GIS system or a CAD system. So here you see that I hit log later. So I open up the line and it's not logging. See, there's a pause symbol in the upper right. So the cool thing here is now I can key in line 2. I don't have to focus on walking or hitting log until I start walking, which I did. And then now as I'm walking, it's collecting positions. And so as you walk, always pay attention to the pencil that is collecting epoch by epoch or second by second. And then you move along, get to the end of the line, you could hit pause. You could finish typing your notes, you could store it, and now if you go to your map view and zoom extents side by side, you'll see clearly vertex to vertex or a point to point line. So here you see a line that was just randomly logged with loose ends at the beginning because it was logging immediately. The other one, you don't see that because you're moving, but you still see it's kind of squiggly or not straight. So how could I even prove that? That's basically done by doing this thing called vertex logging. So by logging later and going to options and hitting log vertex, you'll see on this line, I'm going to do a new vertex, and you'll see it pulse, and these are point style positions. I'll take it up to 10. Those 10 positions will be mean into one good solid position. And now I have a pause symbol 1. That means I have one vertex. I would now just be able to randomly walk, not have to worry about my antenna orientation, to the end of the line. And then when I get to the end of the line, I would just hit options, new vertex again, and you'll see now I'm logging the second vertex. And at 6 positions, 7, 8, 9, 10 positions that auto paused. I can now store my line by clicking done, and now when I zoom extent, you will see I've got 3 styles of line, one logging immediately, now logging later, and then vertex to vertex, and you clearly see that the line that was vertex to vertex is completely straight like it should be, and that is best field practices. Excuse me. So I hope that you see here that the advantage of log now, log later, and vertex, you definitely want to set it to log later, which is not the default. So throughout this presentation, you're going to hear a lot of things about code and carrier. Code phase GPS receivers are what a lot of Trimble mapping people used in the early days with the earlier versions of Geo XTs. It's one processing technique that gathers data via the CA code, or the coarse acquisition code receiver, which uses this information contained in the satellite signal. So there's two types of signals, one's code and one's carrier, and aka this pseudo-random code, and that's why it's called code phase, to calculate positions. After differential correction, this processing technique usually results into anywhere from 50 centimeters to 5 meter of accuracy. And what you need to realize is code phase is what we're using for our phones nowadays still, what like Garmin type devices use, recreational GPS receivers use, and Trimble based receivers that are code phased. Okay, carrier phase receivers is another processing technique that gathers data via the carrier phase of the receiver, which utilizes this radio signal, aka the carrier signal, to calculate positions. What you need to realize is if you looked at the code signal, it'd be like looking at just a standard signal wave, and carrier would be looking at that signal wave in more in depthly under a microscope, which has a bunch of additional information that's at a higher frequency than a pseudo-random code, and this is more accurate than using the pseudo-random code alone. So the pseudo-random code narrows the reference position, then the carrier narrows the reference even more. So after differential correction, this processing technique typically can result in nowadays centimeter even, but sub-decimeter accuracy. So why am I bringing this up? Well, these are the code-based receivers in our portfolio today. Some of you might not realize that, but some of them are surf-based, and we'll get into that in a second, and using a non-Trimble type of GNSS receiver, but some are using Trimble's internal receiver. But the accuracies you'll see here typically range anywhere from 50 centimeters post-process to 75 centimeters on the new Trimble R1, and to 2 to 5 meters using surf-based receivers. That's so what we're trying to show you here is these are code-based receivers, and yes, some of these receivers look like carrier-based receivers, but they're a different type of receiver internally. The carrier-based processing receivers in our portfolio, some of you might even heard of these in 2005 is when the beginning of this started. They were called H-star based receivers. In today's presentation, and you might have attended one of these presentations back in 2013, we called it H-star. The reason why, so just for educational purposes, I want you to know that back in 2005, and I worked at Trimble then, we didn't want a lot of people to realize that how we were doing some of this H-star based accuracy was using carrier, so we called the technology H-star, and H-star did consist of a GNSS survey grade type of chip, better math, and but collecting carrier. Fast forward, every manufacturer that's doing decimeter or centimeter now, and so we don't really need to camouflage or hide the fact that we're doing carrier-based processing. So as you can see, the Pro XRT, the new Trimble R2 receiver, that's capable of going anywhere from a centimeter to decimeter, which is 10 centimeters, and the Geo 6007 series receiver is very capable of doing, again, centimeter or decimeter accuracy. And what you really need to realize is that on the R2 and Geo 7 series, that chip set in those receivers are the exact high-end chipset that you see in a Trimble R8 scalable or a Trimble R10 receiver. It's just being taught or told to do things in a different accuracy for mapping high accuracy GIS data collection. But in these receivers, be aware that They are capable of doing anywhere from centimeter with an option turned on and the right software, and or decimeter accuracy, typically with carrier-based receivers, and that's post-process or in real time. So transition again, some best positions for best practices for collecting data. If you don't know this, we highly recommend about 10 seconds at each point features or a vertex. That's why you saw me set that up. And why do I do that? It increases the chance of canceling out multipath errors is one thing. And then also, if the PPA or CEA is poor, you may need to log longer. So if you're real time, that means you're looking at the CEA and you're seeing the CEA get better, then log longer. If you see the CEA getting worse, then you wouldn't want to log longer. Same thing for the PPA. If you're seeing the PPA get better, then I'd stay on the point longer. If you see the PPA getting worse, then you don't want to log more information. Also today, with all these receivers, it is encouraged that you would log at 1 second logging rate. It's better, you have plenty of memory, it's better to log at a faster logging rate than a slower logging rate than years previously. So if you're using a fairly modern GNSS receiver from Trimble, log at a 1 second logging rate. Collect good GPS measurements between features. What are we trying to say here is post-processing will use all the information before and after a feature. So with that said, it's important to remember if you're collecting data and you're on the move, well, collecting good GPS information in between features is important. So what I might mean by that is if you're using this is very critical if you're using like an H-star receiver or a Floodlight based receiver, if you're collecting information and you basically are going to move from one point to another point that's a great distance, it would be better to disconnect GNSS and then drive from one point to another point and reconnect GNSS than it is to not disconnect GNSS, throw the GPS receiver in the bottom of your vehicle on the floorboard and drive it to the next point, get out, and immediately start collecting data. That would be very bad practice and not yield to good data collection or good positions. So whenever possible, also try to collect 30 to 60 seconds, and if possible, like I said before, with carrier-based receivers, 2 minutes of good data before and after a tough feature. What I mean by that, if I'm working up in Alaska and I know I'm getting ready to go on some canopy with an H-star based Floodlight receiver, what I would want to do is, stop and smell the roses, we call it, let it cook and watch that carrier time, like you saw in that video under receiver status. Wait for 2 minutes of carrier time. Then I know I have plenty of good data prior to going into that tough feature. Go collect the stuff that I need to in the tough GNS environment, and then come back out. And again, just stop and chill. Collect 2 more minutes of carrier data, and you'll see that you'll start to get a lot better processing or improvement in your accuracy using that technique. So real quickly, this video is going to show how am I using carrier code. I'm going to speed it up because we're running because of time. Right here you see that my carrier time is about 4 seconds. And it's important that you'll notice that once this gets to about 2 minutes, things will start to improve all around, okay? So if I speed this up, what we're trying to show here is pay attention to your signal noise ratios on L1, L2 on a GNSS receiver. High signal to noise is good. And then if I speed this up a little faster here, you notice I have 2 minutes of carrier time, right? That's important. And now I'm going to connect into a real-time source using VRS. And what this is trying to show you is I'm connected to a real-time source, and I get a lot of calls in and says, hey, let me pause that. Whoops, sorry. Let me bring that back up. Sorry about that. I had a little technical difficulty. If I come right to here, I've got carrier, I've got real time coming in, and what this is trying to show you is I get a lot of phone calls that, hey, look, I'm connected to a real-time source. My unit's typically capable of doing 10 centimeters or a centimeter, but I'm only getting like 30 to 50 centimeters. Our units are very good, and so they can actually do DGPS quite accurately. So differential GPS would be code-based corrections. So if you're hitting a real-time single base in Alaska, and you notice that you're not getting the specification of our receiver, which is 10 centimeters or centimeter, I would challenge you to look under status receiver, and this will probably say code corrections. If you're hitting code corrections, that means your mount point or your information that you're getting over real time is not carrier, it's code, and you just physically of getting the wrong type of information, and the receiver is doing a better than specifications, and that's why you're at 30 to 50 and not near a meter. So in essence, even though you're at 30 to 50, you're doing much better than you should be, but you're not hitting the type of information here, carrier, that you should be getting to be able to hit decimeter or centimeter based on your receiver settings, and that's what we're trying to show you here. So we're going to move through this legacy field settings. I hit these slides. What I do want to tell anybody on the call, if you're still using TerraSync 4 and Pathfinder 4, please contact Mark, and we can send you a link to a recording that we did about 3 years ago on how to get the best use and the right settings for this legacy type of receivers. But due to time here, I'm going to move this to the meat of the matter, which is the 5.0. But Steve just posted a poll, and I would encourage you guys to please take that poll so we can let me go ahead and do this real fast. Steve, is that poll going? I saw it pop up. I'm sorry.
Yeah, the first one's going right now on who using Pathfinder Office and what version.
Okay, so guys, if you can, ladies and gents, please fill that poll out, because that way we'll kind of know on this Alaska market, are you a TerraSync PFO 4 or GPS Correct 3? You know, that's important for us to know. But I'm going to move along as that poll's going on. If you guys to TerraSync 5 and version 5, what you need to know today is, if you're been using Trimble software for many years, that's why we wanted to have that poll. There used to be a slider bar, and it was very important in how settings were, if you're going to post-process or if things were real-time, okay? And so if you are still a 4 or user, please reach into us later or afterwards, and I can help you make sure that those are set up for the best for post-processing or best for real-time. That slider bar is removed from handhelds because we now use a thing called smart setting. So you just let the software collect all the information possible, and therefore it can do the best in post-processing and the best real-time, and there's nothing you need to do. And that's very important because it makes your life a lot easier. However, if you're running legacy software, I would encourage you to reach into us, because it does matter how that slider bar is set up. For example, I will just give you a Cliff Note version. If you are post-processing and using Pathfinder Office version 5, and you still have a slider bar, please have that slider slid all the way over to the left, which is productivity and not precision. However, if you're using real time and you do need that slid all the way over to precision, because that means you're setting up DOPS, SNRs, and elevation mass to get the very best data live in the field. However, one last thing here on the smart settings, if for some reason your agency hasn't moved with, I guess, the times and is requiring certain PDOPs, certain HDOPs, or certain elevation and signal to noise mask, you are more than capable of turning off the smart settings and then going back into the manual mode of like a PDOP of 6, SNR of X, 40, and then an elevation mass of 15. That's still capable. However, I would encourage you to have your agency update their policy and say to use smart settings, because Trimble's done a lot of math and testing with the algorithms so that smart settings will actually be able to do the best work post-processing and also the best work if you're using real time. So let's move into surf-based receivers, and surf-based receivers' best collection practices, which you need to understand. With a surf-based type of receiver, and these are just the latest R1, Junos, and Juno 5s and 3s. These are surf-based chips, how you want to collect data is typically, I would collect, again, 10 good GPS positions at each point in vertex, and also it's important if you could log, again, good data prior and good data at the end if you came from a hostile environment. Wait 10 seconds before logging GPS features when you arrive. There's some drift that happens with surf-based receivers, so if you were moving fairly quickly, it's good to kind of just wait a few seconds, let it stabilize, and then collect data. Even though you might have already realized this, you could probably put any of these 3 receivers, the R1, in your pocket, in a pouch, and it will still collect and get GNSS positions. That doesn't mean that you can't get better positions by, hey, putting the antenna, knowing where the antenna is. For example, I will show you on this Trimble R1, the antenna is up here. So truthfully, the best way to collect data is have this thing standing up with the antenna facing to the sky, not laid down flat on the ground. Some people think this whole thing's the antenna, and it's not. It's really right up here on a coil. So just trying to make sure you understand how to orientate that antenna, and that's important. What we're trying to say here, it's kind of we're just joking, but if you're, what should you do before starting to collect data with a surf-based receiver? A, take a deep breath, stop and smell the roses, phone a friend, or wait 10 seconds before logging. What we're trying to say is the answer would be B, stop and smell the roses. The 10 seconds before logging is just moving point to point to stabilize. The stop and smell the roses is the trick question here before starting. If you can get 2 minutes of carrier of Doppler or carrier data, it's always important. So hey, just stop, let it get some data, and then boom, measure. What we're trying to show you here is just a Juno SB without smoothing, and the yellow lines with smoothing, and you can clearly see the smoothing can assist. So let's transition now to code-based receivers, and that's like XTs, typically the XT line of Trimble. More positions are better if you didn't know this. So now you notice we're going from 10 to now 30 positions. And so I would encourage you to collect 30. That's what I do, 30 to 60. That's the best way of collecting XT data. You might be in a non-hostile environment able to get away with 10, and you're seeing that you're getting fantastic data. That's great. But if you didn't know this, a little bit more and might get you a little bit better precisions, which results in the accuracy translation. Keeping that antenna well orientated is important. Again, antenna placement, like we mentioned earlier, avoid obstructions when possible. So, a lot of people have these in their hands, so you keep them right next to a vault box instead of, having it above the vault box, so you reduce the multipath off the metal, and those things are important. Again, what I mentioned earlier, consider disconnecting GNSS or GPS when you're moving between points. If you can't keep that antenna well oriented, that will produce this no junk data, because remember, we are collecting data in between, and that data does help or not help on the post-processing side. So in the end, try to avoid blocking satellites, what we've shown. These receivers are very sensitive and can lose carrier lock by just passing your hand over it. How you can avoid that is use an external antenna, and that antenna usually has a better ground plane, better yield, which means translates into better precisions. What I'm going to do, based on time here, guys, I'm going to move along here to the XT here. You're seeing, again, a surf-based receiver purple, a yellow with smoothing, and now you see both red with an XT receiver. And what we're trying to show you here is that obviously surf-based receivers can collect data, but commercial higher-end Trimble-based receivers do quite well in difficult environments, and this is showing you that that red line is an XT receiver both in and out of the same environment, and doing a much better job than a lesser cost surf-based receiver. We're transitioning now into carrier-based receivers, and now you see there's a Geo 7 series. The Pro XRT is in the new Trimble R2. This new Trimble R2 is capable of talking to iOS, Android, and Windows-based applications. And what's really nice about H-star or carrier-based receivers is that you can get now three-dimensional data at either decimeter or horizontal if things are set up correctly, and a geo model is used in for real time or in the office for post-processing. So when you're collecting carrier data, again, same thing is, hey, how can you do this? Well, what you can do if you have logged that 2 minutes of carrier time, right? So how many positions are recommended for a point feature? Again, that 10 to 30. If you have that 2 minutes of carrier time prior to starting collection, then what should you do before collecting GPS data for a new feature? The answer would be D here. Just start it and stop slacking off, meaning you've got your 2 minutes of carrier, you've got enough prior, so just start collecting data. Again, because carrier processing, post-processing is going to be using all the data collected, it's very important to collect good measurements between features. So that means it's important to keep that antenna well oriented or and avoid obstructions. And that's why using an external antenna while you're moving from point to point is good. So if you're using a handheld Geo 7 carrier and you actually weren't keeping the antenna oriented, you're not doing yourself a favor, so you could disconnect GNSS, right, and then reconnect when you get to the next point if you're moving a great distance and don't want to hold that geo properly. However, again, when you disconnect and reconnect, you would try to get 2 minutes of carrier data prior to collecting that position. Now, that might not work with everybody's workflow. I'm just saying, and ideally 2 minutes before and after moving from a difficult environment enables better carrier measurements. And that's what this thing's saying about turning off the GPS or disconnecting GPS. So again, how you can do that is using an external antenna. A lot of people choose not to, but by using an external antenna, now you don't have to worry about holding that receiver properly orientated and preventing obstructions and multipath from your body and obstruction from your body. almost finished up here. Floodlight best practices. If you don't know this, if you have a floodlight-based receiver, I would encourage you to understand there's a barometer, and you don't want to put a sticker on these barometers that block the barometer from being able to do its job. A floodlight-based receiver had a barometer, a GNSS chip, and math. Those three things is what was the floodlight technology. So that barometer helps you with altitude constrained positioning, but that barometer needs to be what do you call it, calibrated to the outside temperature. If you were working in Alaska and it's cold and you had that G6000 or Pro 6000 series, Pro 6 series in your car, and it's very warm, and then you go outside in let's just say 20-degree or even lower temperatures, that is not going to help you in using floodlight in best environments. It would be better for you to leave that Geo or that Pro 6 series on your hood of your car or your roof, let it become ambient outside temperature, so the barometer will get trilaterate using GPS or GNSS, and then calibrate, and then at the right temperature. Also, you need to realize that if you're using a 6000 series or Pro 6 series, turn off SBAS if you're using, you want floodlight to be performing properly. It's the best way. Now on the Geo 7 series and the Trimble R2, it uses, and the Trimble R1, it uses SBAS Plus, which means it's going to use a combination of SBAS and GLONASS, wide area augmentation system, and GLONASS. So finishing up here, now knowing what you know about best field practices, most of you probably see that an external antenna can be of great use. A lot of you probably avoided because these antennas were quite expensive from Trimble, about $2,500 to about $1,500. What if there was an affordable solution? What I want to tell you is that, and you can verify with like Joel Cusack up in the National Park Service, we sell a third-party antenna solution which is about half the cost. The NPS has been using this quite for some time now, and we sell a lot of these antennas. We have an FPI G5, which is a dual-feed GNSS antenna, very capable to be used with any Trimble system or any system for that matter. And we also have a G8 antenna, which is a quad feed, similar to a Zephyr for 1190. And these antennas can help you tie into your existing receivers to be able to get better yield, better positions, and less multipath by moving it above your body. What I want to do real fast is open it up to any questions and answers, and then wrap up this webinar.
Okay, Mel, thank you. We do have a couple of questions, and I'll get right into them just since we're up against the time clock here. One of the questions is, you were talking about satellites. Are more satellites better? Does it give you a more precise position?
Yeah. So I wouldn't say it's the the answer to that's it's the quality of the signal to noise ratio on that satellite, and so Trimble's going to use all the information and get the best position possible. But so it's not necessarily always more satellites. I would say what's important for Alaska is you saw that those screen snaps were down in the lower 48. As you move in Alaska, the advantage of having GLONASS assisted GNSS receivers, you're going to now not be even at 13. You'll be more at at 8, and you, with a GPS receiver, you wouldn't be able to work. And then from those 8 satellites, the SNR matters. So my best analogy is signal to noise ratio is like is the tether from the satellite to you for position. High signal gives you a very good tethering. So an analogy when I teach is if you're in a room and you're suspended in the room, that signal to noise is high. It's like piano wire, very tight, very good horizontal position. If you change that piano wire out to a rubber band or yarn, which is very sloppy, you notice that horizontally I would move, and that's low signal to noise ratio. So it's not so much the amount of satellites as the quality of the signal to noise ratio.
Okay. You mentioned turning GPS off in the vehicle. Does that include putting it on the dash?
Yeah, because I mean, I would say if you're doing vehicular style collection, I would encourage you to have an external antenna mounted on a mag mount on your roof with a cable that goes into your receiver. And so when you get in the vehicle, you connect to that antenna, and that way you know you're getting very good signal that's not being affected by multipath or reflection through the windshield. And but yeah, I guess if you had to, you could leave it in the windshield, but you know that's still not as ideal as using an external antenna. So I guess what I've seen is especially with A-star based receivers, if it's in the vehicle, now the temperature is much warmer than it is in Alaska outside, and that's not helping the calibration of that barometer. And then when you get out, you have to get it acclimated. And so I would say in Alaska, if you're using an H-star based or Floodlight based receiver, yes, it would be better to disconnect the antenna so the barometer was last calibrated outside. Then you drive and then you reconnect the GNSS when you get to the next point, which is still outside, but not driving it in a vehicle on the dash where the barometer is getting all jacked up.
Sure. Okay. Assuming you'll cover GIS data check-in, check-out practices and latest technologies on that. We didn't cover that in today's session. That's more of the ArcPad checking in, checking out using positions. Is this something we can follow up with Charlie on directly and kind of give him some of those notes offline?
Yeah, we're reaching the mark, and we can work with anybody offline. Today was best field practices, so it wasn't best practices in the office. I would also like to say to anybody that was on this call today, if you'd like to have any future webinars on any topics, relay that through us or myself or Mark Payne and we want to be doing these monthly, and we'd like to have topics so we could go over like best practices for office processing, for example, which includes Pathfinder Office and Trimble positions.
Awesome. Note, I'm just using TerraSync 5. Okay, got that. What kind of accuracy is the R1 capable of both horizontally and vertically?
So it's a code-based receiver. So I didn't stress this earlier, so that was a good question, so I should bring it up. Any code-based receiver is usually 1.5 to 3 times horizontal. So code-based receivers should not be used usually for vertical work. What I mean by that, if it's a 50 centimeter solution, well, so let's answer the question. The Trimble R1 is a 75 centimeter solution, so that means it could be 3 times that vertically, so it could be up to 4 meters to 3 meters vertically, so not much of a vertical solution there. Same with any other code base, like a Geo XT, which is 50 centimeters, let's just say, it would be probably 1.5 meters, vertically is what we've seen. If you want vertical, you really want to use a carrier-based receiver, and I do want to stress that, again, that if you have a decimeter carrier-based receiver, that means it's also decimeter vertical in post-processing if you're using the right techniques with a GUIN model.
Okay. This demonstration will be available for download. Yes, absolutely. This will be available. It is being recorded. We have a little cleanup and some posting to do when we're all done, but I would say look for it in a couple of days on our blog site, and that is www.fpimapping.com. Or you can, I have it noted here, Tom, to just let you know when it's available for download, so I'll make sure we get that to you. What would you consider the lowest threshold for signal to noise ratio?
Yeah, so signal to noise ratios on even a code-based receiver or definitely a carrier-based receiver should be in the 30s and higher. And
okay.
And unless you have some older base receiver, like prior to 2005 or something like that, then 30s might have been as high as it's going to get. But on a modern, newer Trimble receiver, your SNR should be high 30s, even low 40s, and then that means you're getting great signal to noise ratios, and that means you're going to get better data.
Okay. You had gone over the smart settings and settings with TerraSync. Are those same settings available in GPS, correct?
Yeah, so no. So the answer to that is GPS correct, like 3X is like using legacy, it's a legacy software, so you still had, you know, the slider bar and logging pseudo position and stuff like that. So whoever's asking that question, you should reach into to Mark or myself offline, and I can make sure that you're running GPS correct properly, and that was about additional 10 slides about legacy software. That would have taken about another 15-20 minutes, so we omitted that because it's really a whole different animal back using that type of software.
Okay. Yes, ArcPad webinar, excellent. Okay, that looks like it. The rest are just comments. So again, we appreciate the
Hey,
time.
Steve.
We're about 5 minutes over. Yeah, go ahead, Mel.
Yeah, I just want to make sure everybody is seeing my screen here.
We
I
are.
wanted to make sure that the blog is here. When we blog, if you click on blog, the latest blog will be posted right here. And everybody, previous webinars are under webinars here, and previous tech talks or tech talks which are specific and to the point on lots of different things on every software solution we sell. So I would encourage you to make sure you take a look at our blog site and become familiar with our webinars, the past ones that we've done, and then the tech talks, which are very valuable. And one last thing, all this is available also on your smartphone. Just contact, it's an app called Frontier Precision FPI Geospatial. It's available on iOS and Android. So I would encourage you to look at downloading that also. Sorry, Steve.
Yeah, no problem. No, that's a good point. I think that's it for the webinar. I do appreciate everybody's time and look forward to doing this again with you guys, and hopefully you found it informative. Thank you for attending.
Thanks, everybody.